Welcome to Study Loop.
Okay, so I have some information about a bacteria, and I want to use a function that models exponential growth to write a function that models this behavior. So I'm told that I have 100 bacteria to start, and that this bacteria population doubles in 3.5 hours. So after 3.5 hours, I'll end up with 200. So I'm going to use this doubling information to get K. I'm going to divide both sides by 100. I'm going to take the natural log of both sides. I'm doing that because I have to get that exponent K down, and there's no algebraic way to do it. So I use power to a power for logs to drop it down in front. ln of e just equals 1. I don't really need that. And I'm going to divide both sides by 3.5. Okay. I'm told to use 4 decimal places for k. So I am going to take my calculator, press ln of 2, get that value, and then divide by 3.5. And I'm going to get a k of 0.1980. I'm going to now personalize that function using my k. So my function is a of t equals the initial amount, which is 100, e to the, now put in my k, 0.1980 t. Okay, that's part A. In B, I'm asked how many bacteria after 1.5 days. Okay, well, you have to understand that when we calculated our formula, we were working in hours. So the first thing I'm going to have to do, I'm going to have to turn 1.5 days into hours. So 24 hours in a day, I'm going to multiply by 24 hours, and I'm going to get 36 for my time. So when I go into my formula now for B, this is A, I'm going to put in 1980. I'm going to put in 36 for T. Don't put in 1.5. If you put in 1.5, you're saying 1.5 hours. Grab your calculator and raise E to the 0.1980 times 36th power, then multiply that by 100. Okay, you are going to get 1, 2, 4, 6, 3, 8.17. That is bacteria. It sounds like a ton, right? But you have to remember it's doubling every 3.5 hours, and this was after 1.5 days. Okay, the last thing I want to know is when will there be 500,000? So I'm going to set my function equal to 500,000. I'm going to start off by dividing both sides by 100. And I'm going to get 5,000. Just like in the beginning when I had to find k, I'm going to bring natural logs in. Doing that again so that I get to bring that exponent down in front. ln of e is just 1. Don't even need to write it. Divide both sides by 0.1980. Okay, so ln of 5,000 divided by 0.1980 is going to give me a time of 43.02 hours. I don't think it's specified hours or days. No. So 43.02 hours, a little less than 2 days.